Our first topic is apportionment. Apportionment is the process of dividing a set of objects among various individuals or groups. Let me give you an example of that. A particular college has 4 campuses and a total of 18 academic advisors. How many advisors do we assign to each campus? Well, one option is you could take those 18 advisors and split them evenly among 4 campuses. To split something evenly, we could just go ahead and divide our 18 advisors by 4. If we do that, we get an answer that's 4.5. Unfortunately, it doesn't come out to a whole number. So 4.5 advisors per campus. So you'd have to think about, unless you do allow someone to be half-time, let's just worry about whole-time people, you'd have 4 whole people at each campus, and then at a couple of campuses you'd have 5. So how would we decide who gets 4, who gets 5? Well, one of the things we could do is look at the campuses in terms of how many students they serve. And so here we have a table where we have each campus listed and the number of students that are at each campus. So campus A has 560 students. Well, if we went ahead and put 4 advisors there because they are the smallest campus, and B is the next smallest, so we'll put 4 advisors there. And since we aren't quite sure what to do with the extra, why don't we give C and D an extra advisor each? But even if we do that, let's look more closely at the situation. If we have 4 advisors at Campus A that has 560 students, we think about how much work each of those advisors is doing. We could do that by thinking about how many students each one of them advises. 560 divided by 4 would give me 140 students for every advisor. 140 students per advisor. So those advisors, every term, are working with 140 students at Campus A. Whereas Campus B, if you do the same thing, take their students and divide by 4, because they have 1,230 students, you end up getting 307.5 students per advisor. That's a lot more students that the advisors at Campus B are having to advise. And you might say that's not fair. It's not fair to the advisor who is overworked, or it's not fair to the students who get maybe less time with the advisors. You could continue to see inequities even with 5 advisors at the 2 larger campuses. If we have 5 advisors at like the last campus, even though it is more advisors, there's still, because there's 2,350 students, there's so many more students, it's still 470 students per advisor. So there's kind of a workload issue here and an inequality issue in terms of students. So even though this might be one way to split up your employees among the campuses, you'd probably want to do it in a more equitable way. So how might we do that? So how might we, and I'm going to use the new word here, apportion. Apportion, that means divide up the 18 advisors among the 4 campuses so the advisors have the same workload, in other words, the same number of students. So if all the students are divided amongst the advisors, how many students would each advisor work with? Well, what we want to do there is look at all the students, that total, 5,630 students. If we divide those among the 18 advisors, that will tell us, if we wanted it to be even among advisors, how many students we would have. Doing that division, we get 312.8, and I'm rounding there. It comes out to 0.7, etc., but I'm rounding up, students per advisor. So if we wanted it to be an even workload for every advisor, they would serve 312.8 students. Now, obviously, the 0.8 is, we can't have a 0.8 student, but let's leave the decimal there temporarily, because this is our ideal number, but it's not what we could really do in the real world. It would be our ideal. So let's think about how we would use this ideal number to split up the 18 advisors amongst the campuses. Let's start with Campus A. So Campus A has 560 students. If I have an ideal number that 312.8 students would be assigned per advisor, if I take that 560 students that Campus A has and divide by 312.8, I could get the ideal number of advisors from Campus A. So if I do that calculation, I get 1.79. So 1.79 is what we would consider a quota or an ideal number of advisors for Campus A, that quota. And I'm going to put that in the table because I'm going to create those quotas for each campus. So 1.79. Now obviously, as I said, you can't have a whole, or decimal rather, number of advisors at a particular campus. So, but you would think that if I have 1.79, that's telling me that I should either have 1 or 2 advisors. So you could kind of cut off the decimal or round down to create a whole number, or you could round up. Okay, so there's kind of one of two ways you could do that. Campus B, we could do something similar. Just divide again the Campus B's values by, or student number, by 312.8. And if you do that, you'd get 3.93. Once again, a decimal, but that would be the ideal quota, having 3.93 advisors at Campus B. But again, that's unrealistic in terms of a fractional advisor, so you would either have 3 or 4. Campus C, 1,490, I could again divide that by 312.8 to get the ideal number or the quota for the advisors, which would be 4.76. Again, can't have a decimal, so if you cut the decimal off, that's 4 or 5 advisors. And then finally, Campus D, do the same thing, divide by 312.8 for the ideal number of advisors you would assign to Campus D, and that would be 7.51. Which, again, if you cut off the decimal, would be 7, or if you round it up, would be 8. Now, here's the thing, is that these quotas, because they were ideal, should add up to the total number of advisors I had. So if we add these up, 1.79, 3.93, 4.76, 7.51, we should get 18. Well, if I do this, in this instance, I get 17.99. It's not quite 18, but it's really darn close. And you might imagine the reason I'm not getting 18 is through round-off error. It's really close to 18, but from round-off error, because I did round these decimals off, if you were doing this in your calculator, you would know that all 4 of those numbers I entered into that column, I rounded off as I wrote it down. When I do the total, I don't get exactly 18. Sometimes you will, sometimes you won't. Depends on how the round-off works. But either way, that's a nice check to make sure you haven't made a calculation mistake, because your quota total should end up giving us 18, because we want to distribute 18 advisors. Well, if we look at the other two, we had 2 ways of getting rid of that decimal. We could cut it off, and if we just cut off the decimal and add up how many advisors we have 1, 3, 4, and 7. That's 15 advisors. That's too few if I just cut off the decimal. So I have advisors left to assign. If I round up, and all of these numbers, technically, even with round-off, normal rounding rules, would round up. 2, 4, 5, and 8 add up to 19, and that's more than I have. Remember, I only have 18 advisors. So the 2 common ways of dealing with the decimal, which might be to just cut it off or round it off, neither one of those gives us a perfect 18 in the end. So there's going to have to be some kind of decision-making process in terms of which campus gets an extra advisor and which campus doesn't. And what we have in mathematics are different rules for doing this decision with the decimal. And those rules are what we call apportionment rules. And that's what we're going to look at in this chapter.